Hello, in this lesson, we're going to be taking a look at Chapter 11, Lesson 2. And here we're going to talk about finding the area of trapezoids, rhombi, and kites. And so we are going to get to take a break from looking at perimeter, and we'll just get to focus on looking at the area today. So to review, um, find the area of a trapezoid is what we're going to look at first, is basically just one half. Okay, so let me draw this out. So let's say we've got a trapezoid, okay? Trapezoid. And we know that to find the area, we call this our base 1, our base 2, and then there's a height. And no, this makes a right angle. And if we pieced two trapezoids together, you would create like a rectangle or a parallelogram. And so what we see is really, if we add our base 1 plus base 2, multiply that by the height, that is basically doubling this shape and creating like a parallelogram from it. Well, if I am just finding this exact area, then I can just divide that by 2 or multiply by 1/2, and I get the area of a trapezoid. So the area of a trapezoid is 1/2 times height times base 1 plus base 2. So that's your equation here. You can write that down in your notes and have that. But basically, we're going to use that to help us find the area. So let's practice a little bit. And I think this lesson will be a little more straightforward than what we did yesterday, where most of the information, I believe, should be given to us. So here we have our height of 16, our bases are 32 and 18. So this would be 1/2 times 16 times 18 plus 32. And we've got to add the bases together first and then multiply everything else out. So I'm going to put this in parentheses as well so I can group that. And so when I multiply that out and plug that in, area equals 400 square feet. There we go. All right, number 2. So we need to identify the height. Remember, the height is always going to be perpendicular to the base. So the height here is 28. So we're going to do 1/2 times 28 times the two bases added. And you know that the bases are always going to be parallel. So if you're not sure what the bases are, like looking at this, you might think, oh, is this the base? And is this the base? Well, no, they're not parallel. So those are not the bases. So we're going to add this up. 1/2 times 28 times 36. Plug that in. And the answer is 504 square yards. Okay. I don't feel like I have to do all of these with you, so I might do like 4 and 5, and that's it, okay? 4 and 5. So number 4, again, we've got to identify the height is 5. The bases are 8 and 15. Those are parallel, so those stand out as our bases. So it's 1/2 times 5 times 8 plus 15. Add that up, multiply it out, and the area equals 57.5 square inches. Number 5, this one's straightforward. Your height is 6. Your bases are 38 and 21. So 1/2 times 6 times 38 plus 21. Add that up first, then multiply everything else out. The answer is 177 centimeters squared. Okay, looking at number 7, I'm just gonna kind of clarify that this 5 feet is showing like this extra little part here. And so what you have is a trapezoid backyard, and we need to find how many square feet of grass that Ryan has to cut. And the picture is not very clear, but this little segment here is 5, and these are right angles, and then this little segment protruding here is 5. So that means our first base, our base 1, is 20.5. Our second base, our base 2, is 20.5 plus 5 plus 5, so it's 30.5. So, and then the height is 38 and 1/4. So you can turn this into decimals if you want to, but we're gonna write this as 1/2 times 38 and 1/4 times our bases added. So 20.5 plus 30.5. And so if I, work this out, I've got 38 and 1/4 times 51. And so I'm going to plug that in. 51 times 38 and 0.25 really times 0.5 or times a half is 975.375 and that's about your area there for the yard, feet squared. Ooh. Okay, so you get the idea. Hopefully that made sense. Now we're going to take a look at the other two shapes, rhombi and kites. So rhombi and kites both actually have the same formula for finding the area. It's 1/2 times the first diagonal times the second diagonal. So both a rhombus and a kite has a diagonal, and the diagonal goes from the vertex across to the other vertex, and then the other vertex across to the other vertex. And so usually they create a 90-degree angle, and I think we've studied this in the past when we were looking at quadrilaterals. So they make actually a 90-degree angle in between. So looking at this, we need to find the area of the rhombus, and so, or the kite. So number 1, we have this diagonal. The parts are 20 and 20. And then this diagonal, we have the parts as 56 and 26. So each diagonal, you might have to make sure you calculate what the diagonals are. The first diagonal is 40. The second diagonal is 92, 98, or 82, right? So 82. So when we plug this in, we have the area equals 1/2 times 82 times 40. We're multiplying all of them, and then the area equals 1,640 inches squared. And we don't have to find the perimeter, thankfully. Okay, number 2, we've got congruent parts of our diagonal. So 10 and 10, 20 and 20. So that means your diagonal 1 is 20, your diagonal 2 is 40. So then I'm going to write this as 1/2 times 20 times 40. And when I multiply that out, the area equals 400 centimeters squared. All right. Number 3 is likewise, same thing. Number 4, all the parts of the diagonal are the same, which means I have 13 here, 13 here, 13 here. So that means when I multiply out to find the area, it looks like it's 26 times 26 times 1/2. So 1/2 times 26 times 26. And then the area equals 338 centimeters squared. Good. Okay, and all this is pretty straightforward, I think. So I'm going to put the answers up for 3, 5, and 6. You pause the video, work those out, and then you can check your answers. So number 3, it's 672 square feet. And then number 5, it is, I didn't do this one. No, I did. Number 5, it is 112 square meters. And then number 6, it is 108 centimeters squared, or square centimeters, and that's it. Okay, looking down at 7, 8, and 9, we have to work backwards to find the missing part, finding the variable. So I am just going to use the same equation, area equals 1/2 times height times base 1 plus base 2. Now I'm going to plug in the information we have. So the information we have is 1/2 times x, don't know what that is, the height, and then 12.8 plus 20. So now I can work out this problem by working backwards. 1/2 x, and then this added together is 32.8. And order of operations say that I can multiply first in whatever order I want. So I'm going to do 32.8 times 1/2. First, so all I can combine my like terms, 1/2 times 32.8. So I have 16.4 x, and oh, I forgot to put down that the area is given to us actually. So the area is 164. So I'm going to replace this here. Area is 164. And now I'm going to divide 164 by 16.4. When I divide that, I get 10. So the height is 10. Okay. So in your equation here, with the kite or the rhombus, we're going to say area equals 1/2 times diagonal 1 times diagonal 2. So I'm going to plug in all the information I have. This time I'm not going to forget. The area is 340, 1/2 times diagonal 1, I'm going to say 20, and then diagonal 2, I don't know what it is. And it looks like this x is pointing to just half of it, I think. I'm not quite sure. It's not very clear. So we might just calculate what half of it would be. So we can combine these two. 1/2 times 20 is 10 times diagonal 2. And then we're going to divide by 10 on both sides to get d by itself. And this is 34 equals diagonal 2. And so that's the diagonal 2, the whole entire length here. But half of that would be x. So 34 divided by 2 is 17. And so x is 17. Okay. Number 9, area is 247.5, and we're going to use the same equation because it is a kite. So I'm going to do 22.5 times diagonal 2. I don't know what that is. So I'm going to multiply 22.5 by 1/2 and just, combine that so I don't have as many numbers to work with. And then 247.5 divided by 11.25, and it equals 22. So the diagonal 2, second diagonal, is 22, or that x equals 22 mm. And there you go. All right, it looks like this lesson was definitely a little more straightforward. So hopefully that makes sense. And that's all I have for you today.